Okay, so where I would normally start when I come into a file that's being freshly passed on to me, if it's like a raw file that hasn't been touched by anyone, is I would do a test render just to see what it looks like, just to start off. But with Mental Ray, with the new version of Mental Ray, this panel here is your control of quality and minimum maximum samples in your scene, right? So your quality level is it's the way they explain it in their documentation is fairly arbitrary. It's not it goes from point 0.1 to 20, and it's noise reduction, and they don't give an explanation of how it's reducing the noise or anything like that. So it's just as you increase the number, it increases your quality. So it starts off at a default of 0.25, and you increase it accordingly to reduce noise in the scene. So um,
What's the loss? What do you lose if you max it out?
it's just render time.
Render time.
It's more time. That's all it is. It just increases your render time the higher this goes. These, from what I understand from the documentation in these new settings, are fairly innocuous in comparison to the old version. Like this is the old version, and this is how you controlled the minimum and maximum was how you controlled the quality of an image. And in the new one, they're saying that the quality tab is the only thing you should use, and these aren't even really they're not used for anything. So this is kind of dependent on if you think you could use this. They say that this is your best option. So now, as far as these are concerned, down here, I normally don't like to have a bucket width of 32 pixels. It says in the documentation that it doesn't affect render time that much, but I've noticed from experimentation in my own renders, in my own work, that if you have it slightly smaller, around 16, like around here, you'll actually get a faster render result, solely because it's not going to sit on a large block of the image rendering. So it'll actually move around the whole image faster when you're doing test renders, so it actually reduces your own personal time sitting there waiting for a result, as opposed to the entire time for the scene to render, because that's absolute. You're always going to have the same amount of time to render the scene overall, but if you're doing test renders, you want it to be as quick as possible. So having a smaller bucket size allows you to see a result faster. Bucket order, these are dependent on the type of shot you have. So Hilbert is something that comes with Mental Ray. It's specific to Mental Ray. It's a random bucket order pattern, so it goes around the frame in a random order, trying to find the best place to render quicker, so that it will hit like parts of the frame that don't need as many samples, and it'll go to the higher sample ones as it progresses. Spiral is typically used for hair simulation, and then top down and left to right are typically used for like environmental renderings. So it all depends on what you're doing. It's not necessarily super important, with the exception of hair using spiral. So that's that.
That bucket width, that's just really just like that section is allocated for each thread, or
It's not each thread. It's basically, I'll show you what it does here. Easier to explain. This here is a bucket. Those are buckets. So it's allocated for the render. It's not using it per. It's depending on the renderer. It's a per thread thing.
yeah.
Like Arnold does a bucket per thread depending on what you want to do, but Mental Ray doesn't have an option to choose that. Like you can't tell it how many buckets to create. There isn't an option for it, so it's not.
But doesn't it just divide like the number of pixels by the bucket?
Not necessarily.
Not,
It's pixels by bucket. Yes, this is a 16 by 16 pixel bucket, but it's not using like a bucket per CPU thread.
Well, I'm assuming GPU thread, right? So.
Well, if it was GPU thread, we'd be having like tons more. Because I mean, like a CPU has like 8 threads, depending on how many cores, but GPU has like obscene amount. Yeah. So it's not really choosing it per thread. That's available to you. Arnold has the ability to do that. But this one, the mental ray doesn't have a place to choose those numbers. So and yeah, so they're this is a square number, so it's 16 by 16 pixels or 32 by 32. So
So I still don't understand, like, what's the bucket width used for a mental ray then?
it's just determining the size of the area you want to render.
But you're rendering more than just 16 pixels. So
Right, but that's how much it's going to process at once per
okay.
bucket. So
Okay.
it's like it's so
okay, but you don't really get to decide like how many threads that is.
Right,
Okay,
yeah.
Okay. Okay.
Correct. Right. Exactly. So, let's see. So down here is the reflections and refraction settings, and the way these work is this is how many bounces that array of this type will make in the scene. So, and it doesn't process them in order. It processes them by order of where items are in the scene. So, for example, if you have this set like this right now is set to 10 total bounces, but the max depth is only 6, which means that if you have 4 reflection rays, you'll only get 2 refraction bounces after the 4 reflection bounce.
Okay.
So since this is overset, you're always going to hit the ceiling before this actually finishes processing the actual numbers that are here. So it's more beneficial to have this set to 2. And considering that there's nothing refractive in this scene at all, you could just turn refractions off and it wouldn't even matter. So in the case of a lot of these shots that you guys have, you don't really have anything that's a refractive material, so there's no reason to really have refractions on, and it's not gonna, it'll actually speed up your renders without actually changing the way the render looks. So, and then this stuff down here is not really stuff that you guys need to worry about. This is more like, this is for contour rendering if you want to put wire mesh over your models, and motion blur is for when if you eventually want to turn put motion into your shots. Like this is where you would choose your like your shutter, which is this is 0.5 is a 180 degree shutter. So like in a camera, you have a camera has like a shutter that rolls, and so when it's 180 degrees, it means that half of the rolling shutter, which is like a full circle, is open, so that it passes the aperture on the open side at 180 degrees of the speed. So if you put it at 25.25, that's 90 degrees, and then it can be 360 degrees. That's but that's not really used in real film. Offset is the amount of frames that it moves to calculate where the motion's coming from in the motion blur. So if you have the offset set to like 1, it's going to move 1 frame and calculate where the character or whatever's moving is in that time frame. So it's going to go, well, it moved this much space, so I have to calculate the motion blur this far based on the shutter.
So we just make it less. We'll make less motion blur then, pretty much.
Actually, this is what determines your actual motion blur.
Sorry, I mean the duration. You just make less. You want less motion blur.
The offset, if you change it, it just changes the not the length, but like the direction of the motion blur. So if you're choosing like a negative frame range, the motion blur will typically be forward motion blur, and if you choose a positive frame range, it'll be negative. It'll go backwards. So this is more of like an aesthetic choice option, where negative 0.25 would be the standard for if you want it to represent like film.
Yeah. Okay.
So, and then let's see here. This stuff is not necessary. Okay, global tuning parameters. These are all multipliers for your shaders that exist in your scene. So this and all this is doing is it's saying, like, let's say you have a glossy reflection shader that's like a car paint or something, and you have 100 cars in the scene, and you don't want to change all of their shaders to have a specific value for precision on their reflections. You can go in here and change the multiplier, and it'll just apply it to all the shaders. So this is really good for controlling render times and speeds. If you have stuff that isn't necessarily like in focus, and you want to have like the glossy reflections pushed outward, it's not going to matter. So you can just use the multiplier to change it here. So let's see, that covers everything in this window. And then, oh yeah, the contrast and noise threshold. So this one's kind of a big deal for cleaning up an image. What this does is, if I can turn it on, is it working? Yeah, see, I can't turn it on for some reason. I could show you if I could. These files I can't turn diagnostics on. I don't know why. So I could show you what this is doing by turning on the diagnostics setting, but it's not available. What this does is it's basically setting the contrast threshold for sampling. So what that means is when it takes the anti-aliasing sampling, it's going to determine how deep it gets before it clamps that sample so that it doesn't go any further into the contrast. So for example, in this shot, like with the actual render here, like if this was set higher, you would actually have clamp shadows that come out that are darker if this was a higher value. But because it's 0.01, it gives you a nice variation going into the shadows. So this is a control to kind of, if your renders are going really long and you know that there's certain areas that you could clamp without having to worry about it, this is where you would do it. You would just increase your threshold until it was in a place where it was rendering faster and nothing really looked any different. And that's what the diagnostic mode is for under here. But since I can't use it, I can't show you like the diagnostic stuff. Maybe I can do it on Maya. So let's see. So that goes down to the global illumination. So these modes here, the skylight modes, what these basically mean is this one, if you have skylight illumination calculated from final gather, that means that the light will calculate with the final gather pass as part of the ambient light in the scene. And if you have it as skylight from IBL, it will use the environment image that's selected for the light and calculate it as a physical light, like a real light that exists in the scene. They both exist in the scene, but when it's calculated with final gather, it's calculated with all of the other ambient light sources in the scene, such as like if you have a piece of geometry that's being used as an illumination object, that you will have both of them calculated together. If it's separate, then the geometry would be calculated in final gather and the skylight would be calculated as part of the final render. So that's pretty much what these two selections do.
Is one of them like more efficient for rendering?
It depends. I mean, that's it.
If you have a lot of lights, then maybe.
If you have a lot of lights, it's always kind of a good idea to have the IBL, the skylight, in the final gather, because unless you're doing photoreal rendering where you're doing something for visual effects or like trying to match a photo plate, then the skylight illumination from IBL might be more beneficial because you'll have more control of things afterwards. As far as doing it for this stuff, having it in the final gather will make the render a little bit faster. This does like calculate things differently, so it will take longer to render. So brings down to final gather here. So final gather uses points to determine rays that are getting shot out into the scene and figuring out where objects are located so that it can determine whether or not there's an emissive property from that object or not that's lighting the scene, or if it has enough brightness in color variation in comparison to another object to create reflected light off of that object onto another one. So, and the way it works is the point is like they don't really have an explanation for this in the documentation. So it's the way that I've seen it from diagnostic stuff is it shoots a grid from the camera that hits the scene and it calculates distance with the grid and it calculates location. And each point in that grid disperses the amount of rays that are here in the rays per FG point. So let's say if you have like one point that hits, then you have the point and it's going to emit at these settings 8 rays per FG point. So that means that in equilateral or equidistant directions in a full circle, it'll emit 8 rays. The default that it comes in with is 250. So the the whole point of it is to, if it were to hit, like for example, say a point comes out here, it's going to shoot the rays out until it hits a surface and bounces. And that's, the bounces are determined by how many bounces you have set in the scene. So this is set to 10 for this scene, but it comes in defaulted at 0. So it's not something that necessarily has to be used if you're just trying to determine distances. If you want to do bounces where you have this object hit this one and then it bounces off and goes back and forth, then the diffuse bounces are helpful. So as far as like point density is concerned, this is point density is a multiplier that basically it makes the points larger so they overlap each other. And when they overlap each other, the rays are shot out from kind of like a Venn diagram. So it's like you have one point and then one point that overlaps. And when the rays are shot out, they stop gaps from happening where you'd have like a noise gap where the circles hit. So you'd have like 2 light spots and then a black spot. If they're large, if the point density is large enough, the circles overlap and then the rays overlap each other and they don't actually, you don't get gaps in lighting. And then the interpolation is an averaging filter that, as far as the documentation concerns, if you read that, it says that the interpolation will increase your render time. But the reality is that the increase in render time is relative to what the actual render time would be, is if you had to have all of the rays per FG point and the correct point density to get the same quality render that you had with the interpolation.
Mhm.
So the smoothing filter technically makes your renders slightly longer, but in the long run it actually makes them shorter. So this is a way to smooth out the final gathering result without doing without having to like really push your final gather too far. This noise filter here is another, whoops.
But smoothing doesn't necessarily translate to photorealistic image all the time, right?
It depends. Most of the time, photorealism is determined by the shader, and not really the render. And like it's determined by the shader, the color space of the image, and whether or not it's visually matches. Really, that's part of this issue with visual effects, is that there is a science to it, but it's more about aesthetically matching something than it is about like having a specific place to go. Because like a director, for example, will say that that's too real, make it more fake. That's notes we get, is like, you know, that looks too real, I don't want it that real, I want it more fake. So it's kind of, and I've run into that more than once on some shows. So it's like, it's a strange situation to run into, because the whole point of, you would think, for visual effects is to replace realism and to match the plate, but sometimes the director doesn't want that. So it's more about the aesthetic value of what you can push out of the machine. So this here is another noise filter for, this will reduce final gather noise when it's fine, but at the cost of illumination. So the high, and it costs more to render. So the higher this is, you actually have to compensate your lighting for the filter, and depending on the type of shot it is, you might lose a lot of light or you might lose a little light. It depends how you're lighting it. If you're lighting the entire scene with final gather, you're really going to have to throw a lot of compensation in when you use this filter. If you're lighting it with lights and only some final gather as like a supplement for like fill light, then this won't really knock back your stuff too much. But it's just another way that Mental Ray has to kind of interpolate noise and remove it. And as down here, there is another reflections and refractions and max depth setting for the final gather itself. And that's similar to the one that was over here on this tab, where these reflections and refractions for the ray tracer, the final gather has the same thing. And this here, the diffuse bounces, actually calculate into this. And this is something that is in the documentation. It says that if you have these two set to 10 total, and then you have 10 diffuse bounces, when you actually render the file, it increases the max depth of the file to the calculated max depth of these two numbers. So it'll make this 20 without you knowing when you actually render the file remotely. When you do it locally, it's not going to change that. So these numbers actually change based on, since these are not calculated down here, these actually are added into this when you render the file later. So that's something to kind of go into and fix. That's why this is brought in as 0 as a default when you start a new file. And then this is radius interpolation is another way to do the averaging of the points. This interpolation doesn't work when you enable the radius interpolation method. So the way that this works is it uses a radius from the center of the point, and it basically creates a secondary point, from the way I understand it, that averages in the same way that this does, but it uses the original grid that the final gather knocked out. So if this isn't working for you to clean up your scene, you can use this one to clean your scene. So both of these methods have the ability to clean up final gather noise. So, okay, so now GI is a little complicated to get working, because right now I know it's on, but it's not doing anything in this scene. Every object in the scene is set to receive and cast GI light, which means that it's set to basically be an ambient source of reflected light or an actual light source. But it has to have photons to do that, and you have to have an object that shoots the photons. And you can set in the object settings for the let's see, like if we grab a column, you can set in the object settings, I think it's surface properties. Let's see. Well, okay, well, in Maya, in the object settings of the attribute editor, there's the option to set it to be okay. There's in the object settings for the geometry, there is the option to set it to be, it comes in default, but you may have to set it up to do the GI. As it stands now, there isn't any, the GI is not doing anything in this scene, so you don't need to have it on.
Do lights automatically come with emitting photons then automatically?
No, you have to turn that on.
Turn it on too.
Lights have photon settings that you have to turn on. So let's see if we can find. Here's an area. That's the target. Okay, so here's an area light, and so if you go down here to the mental ray indirect illumination, you have to turn on the photons here, GI photons, and you can turn it with. See, these settings are all different between Max and Maya. Maya's settings for all this stuff is totally different than Max's. This comes with like 1 photon for the light, 1 caustic photon for the light, and 1 energy. Those are the multipliers. So if we go here and we look at the photons per light, it's 50,000. So it's shooting out 50,000 photons per light. So if and then it has a rate of decay of 2, which is not necessarily a realistic number depending on what you're looking for. So I think that the thing to think about with this stuff is that this is why the debug mode is actually really helpful, because you can actually look to see where your photons are coming from and see if they're actually working. So I honestly have no idea why this isn't available to use in this scene. So if it was, you could see all these objects. Let's see if I open a new scene.
So what is actually? I actually don't know what GI stands for.
Global illumination.
Oh, okay.
Yeah, so it's doing a calculation based on, it's kind of the same as Final Gather to a certain degree, but
Okay.
Final Gather is more about a refinement process for the global illumination. But the Final Gather calculates more so of the emissive properties of objects, whereas global illumination calculates like what you would have for a sky dome,
Yeah,
for
yeah.
example. So like your shadows and your overall illumination from like a sky. So let's see. Um, okay. Okay. So, well, let's finish this up. I'll figure this out. Okay. So with this, there's a lot of various things that play into the global illumination. So a sample in mental ray that's your calculation of anti-aliasing, and it uses like it's basically like a per ray anti-aliasing sample that's shot from the camera, and everything is determined from your camera view. So the way this is working is it's doing maximum number of photons per sample, which is 8, which means that a sample determines what a sample does is it averages the colors from rays that hit an object, and then it creates a color per pixel based on the average of the rays what the rays basically informed the renderer was there. So your photons per sample could be, if this is your maximum, then 50,000 might be too many or too little to meet the maximum cap for the photons per sample. If you have 50,000 coming out from a light, if there's only one light in the scene, then depending on what's going on based on density in the diagnostic mode, you may or may not be using your cap. So, and then volumes are for like fog and water and stuff like that. So this is for a totally different concept of what's going on. And then you can optimize your noise here for Final Gather so that when you run the GI, it'll do it a little bit slower, but it'll calculate your GI at a lower rate than the Final Gather, so that when they run together, you end up with a much cleaner scene because the Final Gather will refine the global illumination's noise. And then this also has its own max depth setting, just like the Final Gather. And this one's set, the actual max reflections and refractions are set higher than the depth. So just like the other one that was on the renderer tab, you'll end up with a situation where you're not going to get all the bounces that were being preserved from these settings because the max depth is not high enough. But these aren't really necessary for this scene because there isn't really anything reflecting and there isn't really any refractions at all. So, and then these are important ones for your like for saving time rendering, especially if you're doing stills or like if you're rendering a lot of frames where the camera doesn't move. You can calculate the Final Gather and GI to be saved to disk, specifically so that it saves them both as like photon and light maps, and then it imports them so that you don't have to you don't have to recalculate it over and over again. This actually saves you a lot of rendering time when it comes to doing like final renders. And this will also stop crawling noise in your scene. So if you have like, let's say you have a camera that's moving from in this shot that's moving from left to right, but it's only trucking like maybe, I don't know, a couple feet. So the parallax change is not huge. You barely see it. You could render overscan of this shot with the Final Gather, capture the entire Final Gather cache, and then only do it once, and you could render your entire scene using that one cache, and you would never have to recalculate it, and it would render completely fine. which would save tons of time on the back end rendering. Which, let's see. And then, let's see, where's that? There is another setting. Here it is. So this is another option that I overlooked. Final gather points from camera position and final gather points from camera path. What that means is if you have a moving camera that's like moving forward through the scene, you want to project the points along the path, because then it will be able to do it in sequential order when you render it, which will actually help with noise problems, as opposed to doing it with from the camera position. Then it's shooting the grid out from the same spot every time wherever the camera is. With this one, it kind of it will use the path of the camera to generate the grid. So wherever the spline of the camera is going, it will actually generate the grid in a method that follows the actual motion. So this is actually helpful if you have like a large camera move or something like that. Whereas this one is works the best for stills, as it says. But it's this can also be used for animation if you were to freeze the cache with a specific type of thing, with like what I was talking about on this one down here. If you freeze the cache here, and you were to do an overscan render for that, then you would end up with a file that would be suitable for doing like a small camera move. Overscan just means extra pixels outside the frame that they wouldn't be visible. They go outside of your actual aperture, so it's more like it's just extra space that compensates for the camera move. So if you
gets cropped basically.
well, it's basically a crop, because the you're just compensating for where the camera's going, so you don't have to worry about it. And then that pretty much, I think that covers everything here. If you want me to show Maya, I can, but that's not on this machine, right?
Yeah, it's on this one.
Okay.
One thing I wanted to ask is, all of this is under the render setup.
Right.
There are like a ton of tabs on top.
Yeah.
Do we need to worry about when we start with the? So primarily we might not be creating a lot of Max files or Maya files,
Right.
Because we are a software company, and,
Right.
but we would need that to debug some problems that customers would share.
Right.
Like, I'm trying to render this Max file, I'll share with you my entire environment.
Right.
The easiest way to reproduce the problem in our lab is to get the Max file, right? And then
to work with the primary file, yeah.
the primary file, and then try to do the same thing with similar configuration. Hopefully we have the hardware and all that stuff. So that's, we only have to play with the render setup menu is all I was thinking about, as long as we don't have to learn the rest of the stuff, because we're a specifically rendering acceleration.
Well, if you're going to deal with client files, you're going to have to know everything, just because like you're going to get files that have like motion blur and different quality settings and stuff like that. So if it was just comes down to like the global illumination settings, you could have a setting somewhere here that might not. I mean, I know the way that your filter works is post processing, so it obviously has a threshold on the amount of noise that it can process. So without like reducing the actual detail of what's in the scene, so the you might have an end result where the end user is trying to reduce their render time by lowering quality or something like that, whereas and they might not be getting the noise solution solved by your filter because of those options, so it would be something that you would want to be able to mess around with just to fix that. Because this here, like this one here, I didn't talk about this. This is a pixel filter for I know that you have it set to box with yours,
our
right?
filter. So how does the interaction with this filter type list
Right.
with our?
Most artists will change it comes in Gauss by default, and most artists won't touch that, so it's always going to be at Gauss. So that could effectively change the output and look of their renders if it switches it to box, because it's not doing the same filtration that they're seeing when they render it.
But I think, well, I'm not sure if this is what you're asking, but like The only part that the Altus menu would be touching would be like this render part, but all these other panels can be changed, and they might be thinking that the Altus standalone isn't working, but it's rather than some configurations creating more noise than Altus can handle.
Right.
Is that what you're trying to say?
Right. Yeah.
But
exactly.
Altus is like I guess Mac script user interface thing.
Right.
Wouldn't really have to address all these parameters, but we should be able to. We just need to know them if we're trying to debug whether it's Altus or it's whether the other configuration settings.
Right. Yeah. Like so, I get what you're asking. So you're basically saying like to keep the Altus as simple as possible. Right?
Yeah.
Yeah. Right. And that was my suggestion to kind of have it as
Yeah,
like
he already suggested yesterday that we should not be a separate window. We should be embedded into one of these menus.
right.
Okay.
That would be the best way to do it
Okay.
because then it would be more like having the Altus embedded in here would change it from being like a separate, because the way it is now you have controls for some items in the
Yeah.
Altus menu and they're not necessarily things that people may or may not use.
Okay.
You know, so with the way this is set up now, it'd be better to have it embedded in the render window as an option,
Okay.
so that it's something that has to be, I don't know, like competently clicked by the user,
Yeah.
so they know what they're doing with it.
Yeah.
So that would be the better option, and
Right.
that would simplify it too,
Yeah.
significantly. So
Just from a debugging perspective, I was just wondering what we want to do the quickest possible debug.
right.
Or,
Now, it
reproduce-
can't-
reproduction of the problem.
Wait, let me stop this for a second. So I think that covers everything for this, right?